Hello, Professor. We are here to discuss our project, which is utilizing predictive analytics for enhanced cybersecurity in cyber supply chains. We are a team of 5, and my team number is 18. In this presentation, we'll be discussing these contents like problem statements, related works, architecture, experiments and results, future work, conclusion, etc. Abstract of this project, cybersecurity in the modern era demands proactive measures to safeguard the critical cyber supply chain infrastructure. So we will be using predictive analytics of 5 algorithms. The objective is to enhance cyber supply chain security by detecting cyber threats in real time. This research yields a binary classification system designed to ascertain the presence or absence of a cyber threat. This study also contributes significantly to the progress of proactive cybersecurity strategies. Next, moving on to introduction.
Coming to the intersection, cyber supply chain security is critical for reliable service delivery and ensure all over the business continuity with the smart CPS. CPS is nothing but a self-managed reliable system development method. For CPS is cyber physical systems, where it is the challenging domain that handles the extreme tight integration and coordination between the information world and the physical resources. And this paper mainly aims to improve the cyber security, for especially focusing on integrating cyber threat intel and machine learning techniques. And coming to this, we have CML techniques and classification ion algorithms and mapped with CTI properties to predict the attacks. Next.
Coming to the problems and challenges here, that explains about the vulnerability of our infrastructure to cyber threats. It includes the interconnectivity and digital reliance, because this increased interconnectivity exposes to a wide range of cyber threats. And the next is vulnerability to cyber attacks. The nature of this includes malware infections, which can lead to a significant damage. And then the absence of real-time threat detection help them to expose to potentially severe breaches. The next is need for proactive cybersecurity solutions. The solution that we are implementing here, which includes the 5 algorithms of decision trees, LDA, MLP, CNN, and hybrid model, helps to detect and mitigate the threats rapidly. The last of ensuring integrity and resilience helps to resist and recover from the cyber threats quickly. All these challenges can be addressed by a comprehensive approach to develop a predictive model and then updating that to handle the cyber threat. The next.
Coming to the related work, we have gathered a few papers within the last 5 years as per your requirement, and these are the papers which we are presenting in the PPT. And the title of these papers are Increasing the Trustworthiness in the Industrial IoT Networks through a Reliable Cyber Detection Model, and coming to it's a classification of malware attacks using machine learning in the decision tree. Next. Cybersecurity threat modeling for supply chain organization environments and the risk teller, predicting the risk of cyber incidents. We have gone through these all papers, and we have seen how they are implementing the more algorithms in the process of detection of the cyber attacks, and we have gone through a lot of papers. Next.
The proposed solution aims to revolutionize the cyber supply chain security by leveraging advanced predictive analytics and algorithms. Here we are including 5 algorithms that we are using here: decision tree and LDA, MLP classifier, CNN, and the hybrid model. So here we are, this has been done in several advantages like proactive threat detection. The system applies the real-time predictive analysis to proactive detecting the cyber threats, and enhancing accuracy will helps to achieve high accuracy in identifying the complex and evolving threats. And coming to the resource efficiency will helps to automating the threat detection process, reducing the need of existing human intervention, and minimize the resources requirements. Coming to the workflow of the proposed system, here this is how the cyber threat detection process will works. The data collection, pre-processing, finding, modeling, and testing. In the data collection, we will collect the data set of around 7 lakh data set. And coming to the pre-processing, we will perform both the splitting of the data based on training and testing part. For the training and modeling, we will use different classifiers to perform training on all the data set. For the testing, we can make sure of the evaluating the performance matrices like accuracy, precision, recall, and the F1 score for all the data set. And finally, the results will be on whether it is a cyber threat is detected or not. Coming to the architecture, this is how that architecture will performs, where the data was collected from the multiple articles from Kaggle dataset, and the feature engineering will performs the replacing of null values and decoding each of them. Here for feature extraction, here we are using K-based feature extraction, which is applied to the subset of the relevant features from the large set of features in a dataset. This is done due to the reduce the complexity of the model and improves in accuracy and speed of the training processes. Here the K-based algorithm will be done for the overfitting, which refers to the machine learning model performs for training of dataset, which helps in executing bulk of data into and minimizing them into the fitting of complex data. And further, the pre-processing will be helps in training and testing, which can be divided based on the ratios of 80:20 and 70:30 ratio. After splitting the data set, the training model will be executing of 5 algorithms, both ML and DL algorithms. The testing part will be results in the generating results, and finally the output will be whether it is detected or not.
Coming to the experiment and implementation, we have data preparation. So data preparation is a data pre-processing is essential for predictive analysis and machine learning tasks. And we have 3 key reasons for the data pre-processing is needed, where it is handling missing values, where the values are missing, we'll be having then missing values which affect the performance and the predictive models. So the data processing techniques we also have the deletion of records with the missing values, or advanced methods with interpolation can be used for handle the missing data effectively. And the next it will be dealing with the categorical variables, where the categorical variables will be label encoding is a method which converts the categorical variables into a numerical format. Each category is assigned to the unique number value and allow the machine learning algorithms to process the categorical data. And the third will be normalization and scaling. And feature is a data set with different scales and ranges. This can lead to the biased models where the certain feature dominate the learning processes. And at here we have the improving the stability, where transforming the features to have the mean of 0 and the standard deviation of 1 can help and ensure all the features contribute equally to the model training process. And these techniques may include feature scaling, outlier detection, and normalization. By addressing this thing, data is better prepared for the analysis, leading to more accurate and robust predictive models in the cybersecurity and other domains.
Next, we have feature engineering and selection. By utilizing cyber threat intelligence to extract relevant features such as malware signatures, indicators of compromise, network traffic patterns, and historical data. Next, we have model selection and training. We implemented 5 different ML and DL algorithms. For this, we split the dataset into training and testing sets and employ techniques like cross-validation for model evaluation. Next, we have evaluation metrics. We evaluate the performance of each model using appropriate metrics such as accuracy, precision, recall, F1 score. Next, we have integration and deployment. Once the effective models are identified, we integrate them into unified predictive. Next we will explain the algorithms used and their execution. First, we have a decision tree classifier. As the name goes, it uses a tree-like model of decisions. A decision tree is drawn upside down with its root at the top. The algorithm splits the dataset into subsets based on the value of input features, aiming to create a tree-like structure where each internal node represents a decision based on a feature. The end of the branch that doesn't split anymore is a decision or a leaf. The diagram shows the structure of a decision tree. First, let's view the results of decision tree classifier before implementing K-based feature. So here are the results for decision tree classifier. We can see accuracy is 100, but precision, recall, and F1 score values are 0. So let's view the results after applying K-based feature selection. We also used hyperparameters. We also used hyperparameter tuning. Here we can clearly see the accuracy, precision, recall, FN score has are now 100. Values are now 100, and best hyperparameters for this classifier are list is shown here. Next, let's move on to next classifier.
Yeah, coming to the next algorithm we are using in this project, it is MLP, which is multi-layer perceptron, is a type of artificial neural networks that consist of multi-layers of nodes or neurons. It is a feed-forward neural network, meaning the connections between nodes do not form circles. Each neuron in one layer connects with a certain weight to every neuron in the subsequent layers, and mainly this MLP consists of 3 layers, which is input layer, hidden layer, and the output layer. And coming to the input layer contains the neurons that represents the input features to the data. Each neuron corresponds to the feature. And coming to the hidden layer, and these are the intermediate layers between the input and output layers. They perform complex transformations on the input data through weighted connections and activation functions. And here, depending upon our the task complexity, we can have more number of hidden layers. If the task is it's not too much complex, we have the limited layers. If it is more complex, then we can have more number of hidden layers. And coming to the output layer, this layer produces the final output of the network based upon the transformations performed by the hidden layer, and the number of neurons in this layer depends upon the problem being solved. And here, like, we are applying the k-best feature selection, and now my teammate will share the screen. Yep. Yeah, before applying the k-best feature selection, we are having this the output parameters, like the accuracy, precision, can be seen on the screen. Yeah, which the accuracy is 100, and the remaining the 3 parameters are remains still 0, and the time taken for this MLP is 0.09 seconds. And once we upload the k-best feature selection, the parameters are like they're achieving the maximum levels, like the accuracy is reaching 98, and precision is 99, and the recall 98, and the fun score 99, and the time taken for training is 0.49 seconds. Here we can see a little bit increase in the time taken for the training, but the output parameters are also increasing. Yep.
Next, coming to the convolution neural network classifier. As we all know, CNN is a deep algorithm designed for processing the structure of grids and data in such images. So the below image which demonstrates the feature extraction to process with the convolution network, highlighting how the convolution layers convolve in input images with learnable filters to detect the features at different spatial hierarchies, followed by pooling layers down to the sample feature maps, emphasizing the CNN ability to automatically learn to exact the meaning of the representation from images in the crucial tasks like object detection and image classification. And we also use here ReLU layer, pooling layer, and flattering layer, and full connection. Overall, this we'll finally know how the produced learn in the classification of images. So now we'll be seeing the program run for the CNN algorithm. So we'll be having 2 different bits, k-best feature selection before and k-best feature, and this is going to be the before. And at here we have the model fit, which echo is 5. So at here we can see the accuracy is 0.190 and the loss is 0.306. And after the test, we can see the overall is 4.090. And coming to after the k-best, at here we can see the model evaluate. At here we again took the echo is 5. So it's just, you can take any number. For right now we have took only 5. So the accuracy has been 0.9900 and the loss has been 0.3011. Can we have, and the test accuracy has been 98.66. Moving to the next classifier.
Coming to linear discriminant analysis, it is commonly used in the field of pattern recognition. It is used to find the linear combinations of feature that best separates multiple classes within the data set. It does so by maximizing the separation between classes while simultaneously minimizing the variation within each class. One of the main advantage of LDA is that its ability to reduce the dimensionality of the data while preserving most of the information. Overall, it offers a robust method, making it a valuable tool in many machine learning applications, includes face recognition, speech recognition, and medical diagnosis. Coming to the code execution before the k-based feature selection. Here we'll consider various metrics like accuracy, precision, recall, and F1 score. So before, it takes a time of 0.14 seconds and the accuracy is of 100. Now after applying the k-based feature selection for these all metrics, we will have the accuracy of 99.7, and the other metrics have these values like 99.6, 100, and 99. And the total time taken for the prediction is 0.01 seconds. The next classifier is that
Coming to the second classifier, the hybrid model integrates the combination of both LDA and the MLP classifiers, which strengthens and enhances the predictive performance. By leveraging the LDA ability to extract the discriminant features, and MLP will help to the capacity of learning complex patterns. The hybrid model, which achieves balancing the approach of classifying tasks. It benefits from both the algorithms like LDA feature transformation to enhance the data representation, and followed by MLP, which learns the capabilities to find the grained decision making, which results in improved accuracy and results in the diverse data sets. Now you can see the combination of both ML and DL algorithms of LDA and MLP, which helps in before data feature extraction, which helps in the results of less than 70, with the combination of time taking for the training and the prediction. And once it was done after the execution of data extraction for the k-based, now you can see the combination of LDA and MLP with the accuracy of 0.99%, and which results in the 0 results in the detection and 1 results in the detected cyber attack.
Next, we have the enhanced visual analysis for the model performances, where we have the correlation heat map is a graphical representation for the showcases of the correlation difference between the variables in a data set, where the brighter colors, example red, indicates a stronger positive correlation, while the darker colors, example blue, indicates a stronger negative correlation. Next, the heat map. Heat map is a graphical representation that uses the color intensity to visualize the data values on a two-dimensional surfaces. Mainly, these are configured in the heat map by region, category, industry, and time region to increase the relevancy of the data of your organization. Next.
Coming to the count plot, here you can see the count plot was applied for the data set and for all the data. Now you can see it has been make sure it has detected as 0 and the not detected as 1. Detection was done with this ratio and not detected as with the 1. And apart from the count plot, we can have the join plot as well for each of the column, and the box plot for each of them, which ranges in each one of them.
Yeah, and here we are visually representing the parameters for our algorithms, which is the accuracy, precision, and the recall, and the F1 score. And yeah, like mainly precision mean accuracy, like out of all predictions we made, like how many were true, like and coming to the precision, like out of all positive predictions we made, how many were true, and the formula for the precision is true positive by true positive plus false positive. And coming to the recall, out of all data points that should be predicted as true, how many did we correctly predict as true? And the formula for the recall is true positive by true positive plus false negative. And coming to the F1 score is a measure that combines both the recall and precision. As we have seen, there is a trade-off between the precision and recall, and here we are using the bar graph, and the blue color indicates the LDA algorithm, and the coming to its next is the decision tree, and the next green one is multi-layer perceptron, and the CNN followed by the stacking classifier. Like here we can see we have the decision tree and the stacking classifier and the CNN. They are achieving 100, which is a good, so that they are predicting more accurately.
We will show the results of after execution of the project. This shows a home page, login page, and registration. So once a user has registered in this website, his details will be stored under cyber table in our database. Next, let's log in. So once the user logins, he can see these options like upload data, view data, pre-processing model, etc. Let's upload and view our data first. We have gathered like 700K records from Kaggle and Microsoft websites. So this is the data. Next, we will go for pre-processing, where we enter the split size, which helps in pre-processing. Next, let's move on to model.
Here we'll have the prediction of the metrics of various metrics like accuracy, precision, recall, and F1 score. These are the values for each of the predictions. Then for the prediction, we'll have various parameters like RTP, which is a real-time prediction to determine whether it's active or not, and other parameters like SSX, SXS passive mode to determine the mode, and the default browser identifier, and also the next is whether antivirus products are installed or not, and then which identifies the city, locale, OS, and the region for all the prediction results.
Coming to the implication. The implication comes on integrating of CITE with the ML models for cyber threat prediction holds significant implications for enhancing cyber supply chain security. By accurately identifying and predicting the threats like spyware and ransomware and the phishing, it can be implemented to the mitigating risk effectively. This approach enables the proactive measures against the potential cyber attacks, thereby safeguarding critical supply chain infrastructure and data. Moreover, the deployment of predictive analytics systems will be by CTI data empower cybersecurity professionals to make sure the informed decision and they allocate resources effectively to counter emerging threats. Coming to the future works.
The future works mainly focus on addressing the limitations we have currently. The first is enhancing data sources, the cyber threat intelligence sources, so that we could improve the robustness of models. And by using advanced ML techniques, we can improve the performance. And through integration of real-time data streams and also using approaches like anomaly detection, we can reduce the risks. And also the studies examine that adaptability of the predictive models will help to provide valuable insights in practical implementation. Coming to conclusion.
So, in conclusion, we believe the integration of cyber threat intelligence with advanced machine learning algorithms along with K-based feature selection and hyperparameter tuning, offers a robust approach to enhancing cyber supply chain security. And by leveraging predictive analytics and identifying major threats such as attacks, tailored controls can be implemented to mitigate risks. This proactive approach enables organizations to stay ahead of emerging threats and ensure the resilience of the supply chain operations while effectively detecting cyber threats. We have also added a few reference papers. Thank you.
Thank you.